Okay, we'll see this problem. Valid Sudoku. Okay, so here this is an n cross n matrix. Okay, now determine what you have to do. We have to determine whether the Sudoku board is valid or not. Okay, you have to validate based on these rules. Okay, each row must contain digit 1 to 9 without repetition. Right, it should not contain any number which is greater than 9, and it should be between 1 to 9, and the number should not repeat between rows, and each column must contain digit without repetition. Same, the column also, it should not contain duplicate elements. And similarly, each subboxes, right? So subboxes is this three cost. This is one subbox. This is another subbox. Okay. This also should not contain duplicate elements. Okay. There can be empty elements, and empty elements is denoted by, let's see how the empty elements are denoted. The empty elements will be denoted by a dot. Right here, if you see, the same board is represented in a 2 cross 2 matrix. Okay, so if first element is 5, second element is 3, the third element is empty, empty means dot. Okay, so that's how it is represented. We have to check whether the Sudoku is valid or not. Okay, so in this case, all the elements in all the rows are unique, all the elements in all the columns are unique, and all the elements in all the boxes are unique. If that is the case, then we can return true. Okay, if in this case, if you see, right, so in this box, the first box here only 8 is there, the same 8 is there. So this is false. Okay, so now what is the logic to solve this problem? We just need to return whether the solution is valid or not. So return is just true or false. Just pause the video and think of a logic. Okay, so the logic is so simple. What I am going to do is, for every row, right? For every row, I will have a set, right? For every row, I will have a set. I will identify that particular set using a key, which is the row number. Okay, so I will have a collection of sets, right? Basically, like you can think of a dictionary, right? You can think of a row dictionary where where the value will be list of all items in the row, and the key will be the row number, row number. Right? This is for row. Similarly, I will have a dictionary for column number, and I have a list of numbers for that column. Okay. So for any particular column, right? For this column, I will have a list. For next column, I will have a list. Similarly, for all boxes, I will have a list. Right? For this box, so I have to identify the box number. Right? So you can identify the box number. So this is box number 0 or 1. This is 2, 3. Okay. So you need to find a unique way to identify a box number. Okay. There are actually 9 boxes are there. So box number and a list of items in that box. So I will have a dictionary like this. Okay. And I will go through all the items. I traverse through all the items. Okay, we can find the number of rows and number of columns in two loops. You can I think in one loop of rows, list of rows, and another loop for list of columns. I can traverse all the items, and I have to check whether that item is present in that particular row set, this is a set, right? Not a list. Okay. Or you can have a list also. Okay, a particular row set, a particular column set, a particular box set. If it is present, if the particular item is present in the particular row set, column set, or box set. If the item is present, then obviously you can return false because it's a duplicate element. If item is not present, then you can add the value to that particular appropriate set. Okay. When the loop ends and it comes out, probably if any duplicate finds, then it will have written false. The loop ends and if you come out, you can return true, which means that the Sudoku is valid. Like you didn't find any duplicate elements. Okay. So this is the logic, right? You take any item, right? You need to find out whether that item already came in that particular row, particular column, and particular box. For that, we need to keep track. like how it contains duplicate we did, right? So we need to keep track of all the items we traversed in that column. Okay, and that is how we have this. Okay, so let's look at the code now. So I'm having three set of dictionaries for rows, column, and box. Okay, so so this is a 2 cross 2 matrix, correct? Okay, this is a 2 cross 2 matrix. Basically, you have right a length, the length of board, right? Suppose if you have a 2 cross 2 matrix, right, it will be like this, right? 5, 3, 7. This is in the first row, and the second row will be 6, some empty space, 1, 9, 5, like that, right? So these all are other empty things are there. So basically, size of the outer array will give the number of rows, correct? Now this many elements are there. Okay, so south of the outer array will give the number of rows, and south size of the first index, right? First element, right? It will give the number of columns. Size of this array is nothing but the number of columns. This is nothing but number of columns. Okay, so I'm looping through all the number of rows and number of columns. Okay, if it is the dot, I need not do anything. Go out of it. Then I'm checking whether it is present in the particular row, right? The particular row is again as set, right? If it is not, if it is present now, then it is a duplicate element. I'm returning false. If it is not there, then I'm adding that element to that dictionary, right? So this because each element is a set, so I can add to it. The value in the dictionary is a set. Similarly, what I'm checking, I have to check same thing for the column. If that particular this is item is in that particular corresponding column set, then it is false. Otherwise, I'm adding to the corresponding column set. I will have 9 column sets and 9 row sets. Okay. Now I need to identify the corresponding box. So the one logic to identify the box, right? I'm using the rows and the column, right? Based on that, I'm computing the box number. Okay. So suppose if the row is here, right? Uh, any number, if I do a integer division 3, right? There are 9 rows, correct? Which is 0 to 8. Okay, when I do integer division 3, I can get the row of that box. Okay. Similarly, when I do a integer division of column by 3, right? I will get the column of that particular box. So row and column of the particular box I will get. Okay. So for example, you take any number here. Okay. Let's take a number here. Okay. What is the row here? The row starts with 0, right? So 0, 1, 2, 3, 4. 4 is the row. Okay. And column is 0, 1, 2, 3, 4, 5, 6, 7. 7 is the column. When I do an integer division 3, right? This will be 1 and this will be 3, it will be 2. Right? Correct? So, so it will be first row and second column. So this box will be 0, comma 0. This box will be 0, comma 1. This will be 0, comma 2. And this will be 0, comma, this will be 1, comma 0, 1, comma 1. Okay, 1, comma 0, 1, comma 1, and 1, comma 2. So I can identify the box with the integer division, right? So if it is not there, I'm adding to the corresponding thing. If it is there, returning false. If the loop finishes, then I'm returning true. The Sudoku is valid. Any duplicate element found, I'm returning false. Just you can think yourself, right? How to identify the box. Okay, you get a number. The row can be from 0 to 9, and the column can be from 0 to 9. Now to identify a box, right? Number how many boxes are there? It's a 3 cross 3 matrix, right? This is first row. This is second row. This is third row. The box wise, if you see. So yeah, how you can reduce 9 to 3? Just divide by 3. So you can identify that particular box. Right, so using this, I'm converting to a tuple. Okay, because key should be immutable, right? So So that is why I'm converting a tuple, and then I'm using that as a key and adding the particular element to that appropriate box set.